Okay, so this is basically a flow rate problem. So flow rate can be found two ways. Flow rate can either be the area, cross-sectional area times the velocity of the fluid moving through, or it can be the volume divided by the time interval that fills up, right? So there's two ways to get flow rate, and these two things are equal to each other. So this is, you have an air duct filling a room, right? And the room's got some dimensions to it. And the question is, how fast is the velocity in this tube? Okay, so basically the flow rate in the tube is equal to the flow rate into the room. Okay, so we just got to figure out which of these two do we use, one for the tube, one for the room. So the room, right, the room, it gives you the dimensions of the room, the height, the width, the length, right? So that should immediately tip you off that you need the volume. So for the room, I'm going to do the room first. So the room, the flow rate equals the volume divided by the time. So the volume is just the dimensions of the room. So 8.2 times 5 times 3.8, right? That's going to be my volume. And the time interval is 12 minutes, right? But we know 12 minutes, we need to turn that into seconds. So 12 minutes, if I multiply this by 60, then that'll give me seconds, and that comes out to 720 seconds. So take this number, divide by 720, and that means the flow rate is 0.199 cubic meters per second. That's the flow rate. So if this is 0.199 cubic meters per second, that means here the flow rate also has to be 0.199 cubic meters per second. Okay, so now let's do the duct. So with the duct, I used volume over time for the first one, but now I'm going to use area times velocity because it gives me the cross-sectional area of this, or not the area, it gives me the diameter, I think, of the, no, radius of the duct, right? So I can use the radius to get the area. So area is pi r squared. So pi times the radius is 12 centimeters, but that's 0.12 meters squared. And if I do this, I get an area of 0.045 square meters. That's my area. So that means the flow rate, which we said before has to equal 0.199, is going to equal the cross-sectional area times the velocity. So if I want velocity, I can just take this, divide the cross-sectional area over, and that'll give me velocity. So that equals 0.199 divided by my area, which I just got 0.045, and that gives me 4.41 meters per second. That's the flow rate of the air going through that tube.